Okay, so let's dive in. I mean, think about looking up at a really, really dark sky filled with stars.
hmm
Haven't you ever just wondered, is there anyone else out there looking back?
Yeah, it's probably one of the biggest questions humans have ever asked, isn't it?
Totally. And it feels like, well, we're maybe getting closer to finding some actual answers.
Well, that's the exciting part, this sort of convergence of that ancient curiosity with some really groundbreaking technology that's coming online.
Right, because for ages it's just been speculation, maybe science fiction.
Exactly. But now we might actually have the tools, the instruments to, move beyond just wondering.
And that's really what we're focusing on today. We've been looking at this BBC World News article. It's from back in June 2021.
hmm Yeah.
And it really sets the stage for this new phase in hunting for life beyond Earth.
It does. It lays out the context really well.
So think of this as like your quick guide to understanding the big shifts happening in astrobiology. The developments that could genuinely change how we see the universe.
Without getting bogged down in all the super technical jargon.
Exactly. Our mission here is pretty clear. Pull out the key stuff from this article. How these new technologies are set to completely shake up our search for, well, cosmic neighbors.
And the potential scale is just uh, staggering when you think about it.
Oh, absolutely.
The article mentions something like 25 billion stars just in our galaxy that are like our sun.
25 billion.
Yeah. And maybe 1 in 5 of those has an Earth-sized planet.
Wow.
But then you add in the hundreds of billions of smaller stars, the red dwarfs.
Right, they're way more common.
And they seem to have even more rocky planets orbiting them. So suddenly you're looking at, potentially hundreds of billions of worlds that could be habitable
Yeah.
in theory.
It just makes your head spin, doesn't it, with numbers like that?
You'd think it'd be crowded out there.
Yeah. You'd think finding life would be easy. But the article points out the tough part, right? Our tech just hasn't been up to the job.
Exactly. We've been looking, but maybe not with powerful enough eyes, so to speak. We haven't had the resolution or the sensitivity needed.
So, okay, the big question then is, how do we fix that? How do we get past those limits?
Well, this is where the article talks about that dramatic boost that was coming. This was written in 2021, remember?
Right.
And it all boils down to some seriously cool new telescope technologies.
Okay, let's start with the big one people have heard about, the James Webb Space Telescope,
Right.
JWST.
The successor to Hubble in many ways.
It was set to launch later that year, October 2021. Huge deal. And the key thing is it's out in space, right?
Yes, way out there, far from Earth's atmosphere.
Which means no blurry effect from the air, like looking through heat haze on a hot day.
Precisely. It gets rid of that distortion. So you get incredibly sharp images, really precise measurements.
And the size. The article mentions its mirror is, what, 6.5 meters across?
Yeah, 6.5 meters, which was twice the size of the biggest space telescope before it. That size means it collects way more light.
More light means you can see fainter, more distant things.
Exactly. And what's really telling is NASA's commitment. The article highlighted that 25% of Webb's initial time.
A whole quarter. That's huge.
Yeah. Dedicated specifically to studying exoplanet atmospheres, planets outside our solar system.
So not just finding planets, but actually sniffing their air, basically.
That's the goal. Its infrared vision is also key, lets it see through cosmic dust and pick up heat signatures. It really shows where the priorities were shifting.
Definitely sending message. But there's a catch, right? The article mentions a limitation.
Well, yeah. Even with Webb's power, it was expected to only really get good atmospheric data from a handful, maybe, of the most ideal Earth-sized planets.
Okay, so the ones that are perfectly positioned, not too cloudy, that sort of thing.
Kind of, yeah. The ones where the conditions are just right for observation. So it's an amazing tool, but maybe not the only tool we need for this job.
Right. It's not the silver bullet for finding life everywhere.
Probably not on its own. And that's where these massive new ground-based telescopes come in.
Ah, okay. The article talks about two of them, right? The GMT and the ELT.
That's them. The Giant Magellan Telescope, GMT, and the extremely large telescope, ELT.
Yeah.
Catchy games.
Tells you what you need to know. And they were aiming to be finished sometime before 2030.
Yeah, under construction. And the scale is just incredible. The GMT mirror system is like 24.5 meters across.
Which is more than double the biggest optical ones we had back then.
Right, and the ELT, even bigger. Almost 40 meters, 39.2 to be exact.
Okay, that's genuinely hard to picture. How do they even build something that big?
It's amazing engineering. But here's the really clever bit the article mentions for these ground telescopes.
What's that?
Deformable mirrors, adaptive optics.
Okay, what does that mean? They wiggle.
Sort of. They have actuators underneath that can change the mirror's shape hundreds or thousands of times a second.
Why would they do that?
To cancel out the twinkling effect, the distortion caused by our own atmosphere.
Ah, so they correct for the blurry air in real time.
Exactly. And the article suggests this tech could let them take images even sharper than Webb in some cases.
Wow. Sharper than a space telescope, but from the ground.
That's the potential,
Yeah.
yeah, because they can compensate for the atmosphere so effectively.
And that sharpness is key, I guess, because these planets are so incredibly far away.
Absolutely vital. We can't go there, right? Not anytime soon.
Yeah.
So our main method, as the article explains, is analyzing the light that passes through their atmospheres.
Okay, so starlight shines through the planet's air as it passes in front of its star.
During a transit.
And we catch that light here on Earth, or with Webb.
Right. And different gases in the atmosphere absorb specific colors, specific wavelengths of that starlight.
Leaving behind a sort of chemical fingerprint in the light spectrum.
Yeah, precisely. It's like analyzing distant smoke signals, as you said earlier, to figure out what's burning.
And up till now, we've mostly only been able to do that for, like, the big gas giants, Jupiter-sized planets.
Yeah, mostly. Their atmospheres are thicker, easier to detect, but we really want to study the smaller, rocky ones, the potential Earths or super-Earths.
Because that's where we think life like ours might exist.
That's the hope. And these new giant telescopes, both Webb and the ground-based ones, are designed to finally give us the power to probe those atmospheres.
To look for those subtle chemical fingerprints in the air of rocky worlds.
Exactly. Looking for things like oxygen, methane, water vapor, signs that might indicate life.
Okay, but just building these amazing telescopes isn't the whole story, is it? The article seemed to stress other important work happening too.
Oh, definitely not. That's a crucial point it makes. Building the hardware is one thing, but you also need the right software, the right methods to make sense of the data.
Right, because you get all this incredibly complex information back.
Yeah, terabytes of it. And you need really robust ways to analyze it accurately.
And the article mentioned that phosphine on Venus thing as a kind of warning.
Exactly. Remember that. A big splash about potential signs of life in Venus's clouds based on detecting phosphine gas.
Yeah, I remember that.
But then other teams reanalyzed the data, used different methods, and argued that the detection might have been, well, an artifact. Maybe improper data processing.
So a potential false alarm because the analysis wasn't quite right.
Possibly. It really highlights how careful we need to be. We need confidence in the results, especially when the stakes are so high.
Makes sense. You don't want to announce finding aliens and then have to say, oops.
Definitely not. And the other huge piece is figuring out what we're even looking for, what actually counts as a sign of life, a biosignature.
Right, because the article says just finding, say, oxygen isn't enough.
Nope. Or water either. Oxygen can be produced by geological processes or sunlight splitting water molecules without any life involved.
Okay, so you could get fooled by a dead planet that just happens to have oxygen.
Potentially, yes. The real challenge, and where a lot of research is happening now, is identifying combinations of molecules or weird ratios of gases that are very hard to explain without biology.
Like what? Give me an example.
Well, a classic one scientists talk about is finding lots of oxygen and lots of methane in the same atmosphere.
Why is that combination special?
Because they react with each other. Chemically, they shouldn't really coexist in large amounts for long, unless something is constantly producing both of them.
Ah, and that something could be life. Like on Earth, plants make oxygen, microbes make methane.
Exactly. So that kind of disequilibrium, that combination, that chemistry alone struggles to maintain, that could be a strong biosignature. But we need to be sure.
So there's a ton of lab work, computer modeling, trying to figure out the most reliable signs.
Yes, understanding planetary chemistry and geology inside out so we know what a normal dead planet's atmosphere should look like and can spot the anomalies.
So putting it all together, it feels like we're really moving from just, gazing and wondering
From centuries of philosophical questions and speculation.
to actually having the tools and hopefully soon the methods to scientifically test the question.
Yeah, it feels like a threshold moment. We're engineering the instruments specifically designed to look for these signs of life.
It's not just about finding life, though, is it? It feels bigger.
I think so. It's about understanding, our own place in the universe. Is life a rare fluke unique to Earth? Or is it a common cosmic phenomena?
Yeah, does life pop up wherever the conditions are?
Finding even microbes elsewhere would be, well, revolutionary for biology and our whole worldview.
Okay, so let's quickly recap the main points from this deep dive based on that article.
Oh, good.
We've seen that while our current tech has limits, this next generation of telescopes, Webb in space, GMT and ELT on the ground, is a massive leap forward.
A transformative leap, yeah. Giving us the power we lacked before.
And the main strategy now is focusing on analyzing the atmospheres of exoplanets, especially the smaller rocky ones, looking for those chemical clues.
Those potential biosignatures.
Yeah.
Right. But it's not just about the telescopes.
No, absolutely. There's also that critical work going on to sharpen our data analysis techniques.
So we don't get false positives.
And to really understand what combinations of molecules are the most trustworthy signs of life.
Getting the interpretation right is just as important as getting the data.
And for you, listening to this, it connects right back to that fundamental curiosity we started with.
These huge scientific endeavors are trying to answer that question you might ask yourself when you look at the stars. Are we alone?
We're potentially on the edge of getting some real clues, maybe even answers.
It's an exciting time to be following this field.
Definitely. So here's maybe a final thought to chew on, something the article hints at but doesn't fully explore. If we do find evidence of life out there, even if it's just simple microbes, how might that change how we think about life right here on Earth? Does it make life here seem less special or maybe more connected to a larger cosmic process?
That's a deep one. How does knowing life can happen elsewhere affect our understanding of its origins and evolution here?
Exactly. Something to ponder as these incredible new eyes start scanning the skies. This deep dive, it's really just kicking off the thinking on some truly enormous questions.